Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P0107 relates to a low-voltage condition detected in the MAP, Manifold Absolute Pressure, sensor circuit on Honda Odyssey models from 2011 to 2017. The MAP sensor plays a crucial role in measuring the engine's intake manifold pressure, which aids in calculating the engine's air density to manage fuel delivery effectively. A proper functioning MAP sensor is essential for optimal engine performance and fuel efficiency. In this case, a low voltage reading indicates potential issues within the sensor or its wiring. Additionally, it's important to record all freeze data and any onboard snapshots before beginning the troubleshooting process, as this data can provide valuable insights into the fault's history. The MAP sensor serves as an essential component of the engine management system, regulating the air-fuel mixture by monitoring the pressure within the engine's intake manifold. Located typically near the throttle body or on the intake manifold itself, the MAP sensor transmits data to the Engine Control Module, ECM. The ECM uses this information to optimize engine performance. A drop in voltage below specified levels, such as readings of about 3 kilopascal or 0.23 volts, triggers the P0107 code. This low reading indicates either a malfunctioning MAP sensor, an issue with its wiring, or problems with the Powertrain Control Module, PCM, which may not process the sensor's signals correctly. Identifying the root cause of this low-voltage situation is critical for restoring proper vehicle function. Several factors could lead to the P0107 code. First and foremost, a faulty MAP sensor cannot accurately report the manifold pressure, leading the ECM to miscalculate the air-fuel mix. Second, wiring issues, such as damaged insulation or loose connections, may create resistance or interrupt the voltage signal to the ECM. These kinds of connections often lead to intermittent failures, making it imperative for technicians to inspect them meticulously. Finally, a malfunctioning PCM could fail to interpret the signals coming from the MAP sensor accurately. Each of these issues must be examined thoroughly, as neglecting even a minor wiring issue could result in ongoing performance problems. The symptoms accompanying the P0107 code typically include poor engine performance and increased fuel consumption due to incorrect air-fuel mixture adjustments. Drivers may also notice a significant drop in power, especially during acceleration, as the engine cannot adapt to the changing air pressure. Another common symptom is the illumination of the check engine light, CEL, on the dashboard, alerting the driver to the underlying issue. In more severe cases, the vehicle may experience stalling or rough engine idling, making repairs essential. Timely diagnosis and rectification of the P0107 code are vital to avoiding long-term engine wear or catastrophic failures. To begin troubleshooting the P0107 code, start by turning the ignition switch to the on position. This action allows the vehicle's onboard diagnostic system to begin collecting data. Next, use the Honda Diagnostic System, HDS, to examine the MAP sensor readings. Ideally, the reading should indicate roughly 3 kilopascals or about 0.23 volts or less. If such values are recorded, this indicates a potential fault with the sensor, requiring further investigation. However, if the readings do not match this criterion, it could suggest an intermittent failure, and the system may be functioning correctly at this moment. In such cases, it is advisable to check for poor connections and loose terminals at both the MAP sensor and its connections to the PCM. After completing the first troubleshooting step, the next step is to turn the ignition switch to the lock position to ensure safety while working on the vehicle's electrical systems. Then, carefully disconnect the MAP sensor from its 3P connector. It is crucial to handle the connector gently to avoid damaging any pins. Upon reconnection, switch the ignition back to on without starting the engine. Again, utilize the HDS to check the map sensor readings. As before, look for values around 3 kilopascals or 0.23 volts or less. If these values are confirmed to be true, proceed to step 12 in the troubleshooting sequence to diagnose further. If not, move on to step 7 for more in-depth testing. In step 7, you will measure the voltage between the map sensor's 3P connector terminals number 1 and number 3 to gain more insight into the sensor's operation. Utilize a reliable digital multimeter for accurate readings. The voltage should ideally be about 5 volts. This is a standard operational voltage for the sensor. Establishing this baseline is crucial as it confirms whether the power supply to the sensor is intact. If the voltage reading does not measure close to 5 volts, this indicates a fault in the power circuit. If the reading is satisfactory, then direct your attention to step 16 to inspect further components involved in the signaling process. For troubleshooting step 8, first ensure that the ignition switch is turned to the lock position. This is a safety measure to prevent any accidental electrical shorts while conducting tests. Next, you will jump the SCS self-diagnostic check signal line using the HDS, which allows for enhanced diagnostic capabilities when checking system integrity. After this, proceed to disconnect the PCM connector B, commonly referred to as the 49P connector. This ensures that you can obtain an accurate continuity test between terminals. It is essential to follow proper protocols while working on the PCM and its connectors to prevent damage. In this final step, your task is to check for continuity between the PCM connector terminal B36 and the map sensor's 3P connector terminal number 3. Performing a continuity test helps ensure that there are no breaks in the circuit. A multimeter is necessary for this procedure, as it measures the electrical continuity effectively. Ensuring an uninterrupted connection is vital for the proper function of the map sensor, as any breaks may lead to the P0107 code being triggered. If continuity exists, this signifies that the circuit is intact, directing your attention towards diagnosing either the PCM or the map sensor further. However, if continuity is not present, further inspection of the wiring and connectors may be required, as this could point to a more serious underlying issue. After completing the necessary repairs related to the P0107 code, it is crucial to perform a final verification to ensure that all issues have been rectified. Begin by conducting another check of the map sensor to confirm it is working correctly and delivering accurate voltage readings. Once this is verified, proceed to clear any stored diagnostic trouble codes, DTCs, from the vehicle's memory, ensuring that the resultant codes will only reflect current issues. Finally, take the vehicle for a test drive under various driving conditions. This step is vital, as it helps ensure that the repairs made were successful and that the P0107 code does not reappear. Monitoring engine performance during this drive will provide further insights into any residual issues that may require additional attention. Implementing preventive maintenance measures can significantly reduce the likelihood of encountering issues related to the P0107 code. Regularly inspecting electrical connections, especially for the map sensor and PCM, helps identify potential problems before they escalate. Additionally, checking wiring for signs of wear and tear, such as fraying or exposure, can prevent future short circuits or intermittent failures. Maintaining clean sensor terminals and ensuring they are free of corrosion promotes better electrical conductivity. Documenting these inspections and performing routine checkups can lead to enhanced vehicle reliability and performance. Staying ahead of potential issues can create a smoother driving experience with fewer unexpected repairs. In conclusion, the DTC P0107 serves as a critical alert regarding issues with the map sensor circuit, often tied to low-voltage conditions. Understanding the role of the map sensor in regulating engine performance underlines its importance in optimizing fuel delivery and maintaining efficiency. Careful inspection of wiring and connections is paramount to resolving the code and avoiding future occurrences. Regular system checks and maintenance can preempt many issues associated with map sensors, ensuring long-term vehicle reliability. By following the outlined troubleshooting steps diligently, technicians can effectively diagnose and remedy such problems, restoring optimal functionality to the Honda Odyssey models from 2011 to 2017. Addressing these matters promptly will undoubtedly enhance both performance and fuel efficiency. Please like and subscribe to the channel. See you next time.